Hello guys, welcome you all for this end-to-end data science session where you're gonna learn a combination of artificial intelligence, machine learning, deep learning, computer vision, natural language processing, NLP, and then generative AI. Everything that you need in order to become a successful data scientist. So hope you guys are enjoying the session. We are enjoying a lot. We are learning a lot. Hope the same thing for you guys. So if you guys stuck anywhere, if you guys need any doubts, please let us know, because like we are here to help you. We are here to help you, guide you, and then mentor you. So make sure like if you have any doubts, just put it in the comment section. We'll take up and we'll solve your doubts. Okay. So yeah, today we're gonna see a session which is like a theory and black box of LDA. So it's a linear discriminant analysis. That is what we're gonna see today. So before going for the session, as always, guys, please make sure that you guys watch all the previous session videos so that you can have a continuation of what we are talking and you can be able to clearly understand what we are telling. Okay, that's the first thing. Okay, so yeah, without wasting any time, let us jump into today's session. Before that, guys, please make sure to subscribe to our channel, so and then press the bell icon so that you can not miss any of the session, because like every day we are just uploading a new session, right? So that you guys doesn't miss any of the session. Okay, you will get the notification. Yeah, let us move on to today's session. So linear discriminant analysis. So what is linear discriminant analysis? It's a dimensionality reduction technique used in machine learning and statistics. It aims to find the optimal linear combination of features that best separates different classes of data. LDA is particularly useful for classification problem where you want to distinguish between multiple variables. Okay, let's fix the context first of all. Okay, LDA is also a dimensionality reduction technique. If you guys have watched the last 3 sessions, right, you guys already know what is LDA. Okay, linear discriminant analysis. If you guys know dimensional reduction, then you guys gonna explain us what is dimensional reduction. Okay, what we're gonna do means we're gonna convert a high dimensional data to a low dimensional data. Simply, let us say a simple context. I need to predict whether the person has a heart disease or not based on different features I'm gonna have. Nearly, like, consider I'm having 1,000 features. Okay, like blood glucose level, blood sugar level, glucose level, blood sugar, everything, right? Everything same. Okay, let's put it in this manner. We are having glucose level. We are having we are having glucose level, what is the blood pressure level, then what is the gender of the person that is having, and then what is their heating habit, like those things. Okay, and we're going to predict whether the person is going to having heart disease or not. So like that we will be having 1,000 records to predict whether the person has a heart disease or not. 1,000 columns. Now I'm going to convert this I dimension of 1,000 columns to only 10 columns, such that those 10 columns is able to represent all other 1,000 columns. I hope like you guys can able to understand, right? So that's the thing. Okay, so we're gonna convert the high dimensional data of 1,000 columns to predict the heart disease. Now we're gonna convert those high dimensional to a lower dimension, such that we will be having only 2-dimensional data. Okay, only very less, that is only 2-dimensional data to predict the same thing. Now storage of those 1,000 columns will be high, right, when compared to only 2 columns, and computationally heavy for 1,000 columns. Now we're going to have only 2 columns, which is very less. Okay, hope you guys can able to understand and you guys are with me. Okay, now that was the same thing that we're going to do with LDA. What is LDA? Somewhat different is it tries to create a line and it tries to separate the data points such that it creates a classification kind of thing, but it also do the same thing of dimensionality reduction. So the data set can be any dimension. It's gonna treat it in a manner that it creates a line and it tries to split the data points as much as possible. You guys can see in the screen, right? So yeah, that is what this. Let us move on to the next thing. Assumption and prerequisites of LDA. Okay, you guys need to know these things before going for the these are the black boxes, I will say. Okay, before going for the coding session, you guys need to know what these things are. Okay, LDA operates under certain assumptions. Data must be normally distributed within each classes, and the variance of different classes should be equal. Curve, mountain curve. Okay, all data should follow a mountain curve, and the variance of the classes in each and every data set should be same. These are the 2 assumptions that we need to make. Then additionally, features should be linearly correlated within the target variable. LDA requires labeled data for training, meaning each data point belongs to known classes. Guys, and one more thing I need to say. We are learning unsupervised learning here, but LDA is an exception case it is belongs to supervised learning, but it comes under dimensionality reduction and it is LDA. Guys, this is an exceptional case. Here you will be having the label LDA comes under supervised learning technique and it is dimensionality direction category. We call this as LDA. Guys, this is gonna be your interview question. Interviewer gonna ask you what is LDA. You will say it is a dimensionality direction conversion of high dimensional to a low dimension. Whether it belongs to supervised or unsupervised, you will blindly say it is unsupervised because like it belongs to a dimensionality direction. No, it's an exception case. LDA belongs to supervised learning because it has the reliability data. Let's move on to the next thing. Let us see what are the assumptions and prerequisites we are having. Normal distribution, each classes should be follow a normal distribution. This assumption ensures that the data point within the classes or cluster around a certain central mean. Okay, because whenever you are having a data point, right, it is like a mountain kind of curve you should have. So there is a central mean. All the data points are congested. I will not say congested, clustered around the mean. Okay, so that is what called as normal distribution. Then we are having equal variance. The variance of different classes should be similar. This means that spread of data points around their respective mean should be relatively consistent across classes. I am saying it can be a mountain, so you should not have a steep curve at the end, then it becomes outlier, right? It is my main value, here my mountain ends, but if the data points goes beyond it, then it becomes an outlier. It should not be like that. So we should have an equal variance. Next, linear relationship. Since it is a linear discriminant analysis, it assumes the data points are linearly distributed. There should be a linear relationship between the features and the target variable. This relationship allows the LDA to find the linear boundary that effectively separate the classes. So I have told right in the first slide itself, we will be having a line in LDA, and this line helps us to separate two different classes in a manner. The data points in one class should have less distance between them when compared to the data points in one class should have more distance between the data points in other class. That's it. Hope you guys can able to understand. And it should also follow a linear relationship. These are the assumptions. Hope you guys can able to understand. Okay. Yeah. Moving on. Okay. What are the objectives of LDA? Simple objectives. Objective of LDA is to find a set of linear discriminants that maximize the separation between classes and while minimizing the variance within each classes. This involves finding the direction in the feature space, the best differentiate the group. Okay, I hope like it's a bit confusing. Let's make the things very simple. Okay, let's make it very simple. Okay, what is an objective? Maximize the separation. I hope like you guys can see the blue color, green color. There should be more separation between them. That is what maximizes the separation. This is one class, this is one class. So there should be maximum distance as much as possible. LDA aims to find the directions that maximize the distance between the means of two different classes or different classes. That's it. Here we are having two classes, class A, class B, and we need to find as much as differences between them. That's it. Okay, you guys can able to understand the first objective, right? Maximize the separation. Then minimize the variance. LDA seeks to minimize the spread of data points within each class, ensures the data points within the classes are closely clustered. Now, you need to minimize the distance between these blue dots because everything belongs to same class. Similarly, you need to minimize the distance between all the green class because everything belongs to same class. Okay. Now, maximize the separation between two classes, multiple classes. Minimize the variance within the classes. That is what the objective, guys. I hope like you guys can able to understand, right? You guys are with me. Okay, so yeah, this is what all about the objectives of LDA. I hope like I'm able to explain this properly. Okay, these are the objectives. Okay, let's move on to the next thing. Okay, math behind LDA. Same thing, I'm gonna justify in a manner of math. That's it. Okay, don't like get shocked or don't get like okay, what we gonna do? They are saying like it's a mathematics. No, don't worry about it. Let's make the thing simpler. Mathematics begins LDA. LDA uses mathematical techniques to find the optimal linear discriminants. It involves calculating the within class scatter matrix and between class scatter matrix. By finding the eigenvectors corresponding to largest eigenvalue of the ratio of this matrix, LDA identifies the direction that best separate the classes. I hope like it is not going to be understandable by you guys, but no problem. Let us make it very simple so that you guys can understand. Okay, let's come with me. Okay, within class cluster like scatter matrix within class, that means we are having a cluster. Okay, we are having the data points class and the data points are within the class. So within class scatter matrix, measure the variance within the class, each class. That is, data points within the class should have the very less variance. That is represented by using within class scatter matrix. Variance. Next. Between class scatter matrix measures the variance between the means of different classes. This is one class, we are having data points. This is another class, we are having another data points. The distance between them, the variance between them is defined by using the between class scatter matrix. Hope you guys able to understand. I'm explaining in a very simpler term so that you guys can able to understand the black box behind the LDA. Okay, I need each one of you to understand the black box so that when we are moving on to the coding session, right, you guys doesn't think about, hey, this man has still the mathematical concept, but like we are just using only 2 lines of code, what it is. Okay, just understand this. Within class scatter matrix means measure the variance within the classes, only one class. That's it. Between class scatter matrix means measure the variance between the data points of 2 different classes. That's it. Okay. Hope you guys can able to understand. Okay, guys. So we will pass here. Okay, because like I have introduced you to LDA and also the mathematics behind it. So let us continue the remaining thing in the next session. Hope you guys have enjoyed this session. If you guys have any doubts, just ping in the comment section, and we are here to take. We will take up and we will solve your doubts. Okay, because like we are here to guide you, mentor you, and help you to become a successful data scientist. So yeah, guys, that's it. That's all about this session. So we will continue this session in the next class. So I hope you guys have enjoyed this session. So if you guys have any doubts, as I mentioned earlier, please make sure that you guys put it in the comment section. We'll take up, we will solve your doubts. And one more thing, guys, make sure to learn each and every session 2 to 3 times. Sir is mentioning like if sir will be mentioning like you need to mention like learn nearly 10 times so that you can able to understand. So for me, at least try to learn 2 to 3 times each and every session so that you can have a better understanding of what we are telling. So yeah, guys, that's all about this session. Thank you, guys. We will all meet in the next session. Bye, guys. Take care. We will all meet in the next session. Bye, guys.